Sign diagrams for g, g prime of t, and g double prime of t are given below. Answer the following questions about the graph of g of t based on these sign diagrams. What are the values of t where the function g is increasing? Well, we know a function is increasing whenever its first derivative is greater than 0. Well, I guess that's of t. So we're looking for where this first derivative is greater than 0. So here's my first derivative, and it's greater than 0 here and here. So on these intervals this way, and this is undefined, so we're clearly not going to include that. That would be an asymptote of some sort. And here. So we are increasing on the interval from negative infinity to negative 5, and then again from 5 to positive infinity. All right, where is g decreasing? Well, g is decreasing whenever the first derivative is less than 0. So we just go to our sign diagrams and notice that we're less than 0 here and here for the first derivative. So on these intervals here and there. Now, if you'll notice, it kind of joins at 0, but do be careful. It isn't an asymptote because it's not undefined, but it is considered a point where it's neither increasing nor decreasing, so we do want to skip over it. So we want to say from negative 5 to 0, and then again from 0 to positive 5. Don't be tempted just to put negative 5 to positive 5. What are the t values where g has a relative maximum? All right, so a relative maximum, that occurs when we go from an interval of let's see, for a maximum we'd want to go from increase to decrease because there at a critical value we would have a maximum. All right, so that means the first derivative would be positive and then to negative. So if you notice from here, we are increasing and then we are decreasing. So it looks like this particular value would be where we have a relative maximum. But that value is undefined. So that's likely an asymptote, and so that can't be included as a maximum. And no other intervals do I go from increase to decrease, so that's the only potential. So we would say that this does not exist. Likewise, what are the t-values where g has a relative minimum? Well, a minimum occurs when you go from decreasing and then turn to increasing. So we need the first derivative to be less than 0 and then greater than 0. That happens here, but at this point, at 5, that is again undefined. So that can't be included as a minimum. So these values do not exist. Okay. What are the t-values where g is concave down? Well, function is concave down whenever its second derivative is less than 0, and then it's concave up whenever its second derivative is greater than 0. So let's check the second derivative and find out. So for concave down, we have negative here and negative there. So we're concave down on this interval and on this interval, and that goes to infinity. So from negative 5 to 0, and then again from 5 to infinity. Where are we concave up? We are concave up on this interval here, because the second derivative is positive. Second derivative is positive here as well, so we are concave up on that interval also. So from negative infinity, to negative 5, and then again from 0 to 5. What are the inflection points in the graph of g? All right, an inflection point is a place where the graph changes concavity. So if you'll notice here, we go from concave up to concave down, but this point right here, it's undefined. So it's not part of the domain, which means we can't include that as a point of a point of inflection. At 0, we also change from concave down to concave up. So that is a point of inflection. That is on the domain, so we can include that. At 5, we change from concave up to concave down, but again, we are undefined there, so that's a bit of a problem. We can't include that as part of the domain. What are the t-values where g is above the x-axis, and what are the t-values where g is below the x-axis? So all that's asking is, where is the function itself, g, greater than 0, and where is the function itself less than 0? So it's essentially the exact same things that we did answering for increasing and concavity. We're just now doing it with the original function. So the original function is below the axis on this interval here, well, on these two intervals, and we're going to join them together with two different sets. So from negative infinity to negative 5, and then negative 5 to 0. Although this is the place where it was below the x-axis, so I got that in the wrong answer blank. Let me switch that out. All right, and then where it's above the x-axis, that's where the function itself is positive. So that's on this interval here and this interval here. So from 0 to 5 and 5 to infinity.